The National Electrical Code, or NEC, addresses the use of electrical nonmetallic tubing, or ENT, in hazardous locations. An apparent contradiction can arise between NEC section 362.12 and NEC section 502.4 A&E. NEC section 362.12 states that equipment installed in hazardous classified locations shall be approved for such locations. NEC section 502.4 A&E states that fixture wires and flexible cords shall not be used between the fixture and its outlet box in Class 1 or Class 2, Division 1 locations, except as permitted for box-type luminaires in section 501.9. The key to resolving this apparent contradiction is understanding the context of each requirement. NEC section 362.12 applies to all equipment installed in hazardous locations, including fixtures and outlet boxes. NEC section 502.4 A&E applies specifically to fixture wires and flexible cords used between a fixture and its outlet box in Class 1 or Class 2, Division 1 locations. The reason for prohibiting the use of fixture wires and flexible cords in these locations is that such wires and cords are generally not considered to be approved for such locations as required by NEC section 362.12. This is because fixture wires and flexible cords are often not designed to withstand the hazardous conditions that may exist in Class 1 or Class 2 Division 1 locations. Therefore, the two requirements are not inherently contradictory. NEC section 362.12 requires all equipment in hazardous locations to be approved for such locations, while NEC section 502.4 A&E clarifies that fixture wires and flexible cords are generally not considered approved for use as a connection means within such locations. To elaborate, consider what constitutes a hazardous location. These are areas where fire or explosion hazards may exist due to flammable gases or vapors, flammable liquids, combustible dust, or ignitable fibers or flyings. The NEC classifies these locations into different classes, divisions, and zones to define the nature and likelihood of the hazard. Class 1 locations involve flammable gases or vapors in the air in sufficient quantities to produce explosive or ignitable mixtures. Class 2 locations involve the presence of combustible dust. Division 1 locations are areas where the hazard is likely to exist under normal operating conditions. Division 2 locations are areas where the hazard is present only under abnormal conditions such as equipment failure or accidental release. With that in mind, the specific requirements for electrical installations in hazardous locations are designed to minimize the risk of ignition. This includes using explosion-proof enclosures, intrinsically safe circuits, and other methods to prevent sparks, arcs, and hot surfaces from igniting the hazardous material. NEC section 362.12 is a general requirement that all equipment used in hazardous locations must be specifically designed and approved for that purpose. This ensures that the equipment will not create a source of ignition. This approval typically involves testing and certification by a recognized testing laboratory such as Underwriters Laboratories, or Intertech, or ETL, to verify that the equipment meets the applicable safety standards for hazardous locations. NEC section 502.4 A&E is a more specific requirement that prohibits the use of fixture wires and flexible cords between a fixture and its outlet box in Class 1, Division 1 and Class 2, Division 1 locations, with a specific exception listed. Fixture wires and flexible cords are typically not designed to be explosion-proof or dust-ignition-proof. They may have thin insulation or be easily damaged, which could create a risk of sparks or arcs. The NEC recognizes that fixture wires and flexible cords may be used in certain limited applications where they are properly protected and do not pose a significant risk of ignition, for example, in the exception noted. Box-type luminaires are designed to contain any sparks or arcs that may occur within the fixture, and they are often approved for use in hazardous locations. However, in general, fixture wires and flexible cords are not suitable for use in Class 1, Division 1 or Class 2, Division 1 locations. Instead, the NEC requires the use of rigid metal conduit, intermediate metal conduit, or other approved wiring methods that provide a high degree of mechanical protection and are suitable for use in hazardous locations. These wiring methods are designed to contain any sparks or arcs that may occur within the conduit and prevent them from igniting the hazardous material. The NEC also requires the use of explosion-proof or dust ignition-proof fittings and boxes to ensure that the entire wiring system is suitable for use in the hazardous location. In summary, the NEC requires that all electrical equipment installed in hazardous locations be approved for that purpose. Fixture wires and flexible cords are generally not considered to be approved for use in Class 1, Division 1 and Class 2, Division 1 locations. Instead, the NEC requires the use of wiring methods and equipment that provide a high degree of mechanical protection and are designed to contain any sparks or arcs that may occur. Therefore, careful consideration is given to wiring methods in hazardous locations to mitigate the risk of an explosion. In addition, understanding the differences between each of the classes and divisions are important. NEC 500.5 describes the Class 1, 2 and 3 locations in detail. Class 1 locations are those in which flammable gases or vapors are or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Class 2 locations are those that are hazardous because of the presence of combustible dust. Class 3 locations are those where ignitable fibers or materials producing combustible flames are present, but not in quantities sufficient to produce explosive or ignitable mixtures. NEC 500.6 details the divisions, with Division 1 having a high likelihood of the hazard and Division 2 having a lower likelihood. Consider a practical example. Imagine a chemical plant where flammable solvents are used. The area where the solvents are stored and handled would likely be classified as a Class 1, Division 1 location. In this area, all electrical equipment, including wiring, fixtures, and devices, would need to be approved for use in Class 1, Division 1 locations. This would mean using explosion-proof enclosures, intrinsically safe circuits, and other methods to prevent ignition. The use of fixture wires and flexible cords would generally not be permitted in this area. However, in an area of the plant where the solvents are only occasionally present, such as a maintenance shop, the area might be classified as a Class 1, Division 2 location. In this area, the requirements for electrical equipment would be less stringent, but still designed to minimize the risk of ignition. The use of fixture wires and flexible cords might be permitted in certain applications, but only if they are properly protected and do not pose a significant risk of ignition. Another example could be a grain elevator, where combustible dust is present. The interior of the elevator would likely be classified as a Class 2, Division 1 location. All electrical equipment in this area would need to be approved for use in Class 2, Division 1 locations, meaning dust ignition-proof enclosures and other methods to prevent the dust from igniting. The use of fixture wires and flexible cords would generally not be permitted. However, in an office area of the grain elevator, where the dust is not normally present, the area might not be classified as a hazardous location. In this area, the requirements for electrical equipment would be the same as for a general-purpose location. The NEC also addresses intrinsically safe circuits, which are defined in Article 504. An intrinsically safe circuit is one in which any spark or thermal effect produced either normally or under specified fault conditions is incapable of causing ignition of a given flammable or combustible material in air under prescribed test conditions. Intrinsically safe circuits are often used in hazardous locations because they provide a high level of safety. They do not require the use of explosion-proof enclosures or other methods to contain explosions. Instead, they rely on limiting the amount of energy available in the circuit so that it cannot cause ignition. The NEC provides detailed requirements for the design, installation, and maintenance of intrinsically safe circuits. These requirements are designed to ensure that the circuits remain intrinsically safe throughout their lifetime. For example, the NEC requires that intrinsically safe circuits be properly grounded and shielded to prevent the introduction of extraneous energy. The NEC also requires that intrinsically safe circuits be regularly inspected and tested to verify that they are still functioning properly. In addition to the NEC, other standards and regulations may apply to electrical installations in hazardous locations. For example, the Occupational Safety and Health Administration, or OSHA, has regulations that address electrical safety in the workplace. These regulations may require employers to provide training to employees who work in hazardous locations and to implement safety procedures to minimize the risk of accidents. It is important to consult all applicable standards and regulations before installing or working on electrical equipment in a hazardous location. Failure to comply with these requirements could result in serious injury or death. In summary, the NEC provides a comprehensive set of requirements for electrical installations in hazardous locations. These requirements are designed to minimize the risk of ignition and protect people and property from fire and explosion. The NEC addresses a wide range of topics, including wiring methods, equipment, intrinsically safe circuits, and other safety measures. It is important to consult the NEC and other applicable standards and regulations before installing or working on electrical equipment in a hazardous location. This is because the ultimate goal is to ensure the safety of people and property in areas where fire or explosion hazards may exist. This means implementing measures to minimize the risk of ignition and prevent accidents. Working in or around hazardous locations mandates safety.